Previously in your algebra life, you did a lot of y equals mx plus b, which gave you a linear graph, meaning a straight line. We're now moving to exponential functions, which will be nonlinear or curvy, and they can take on many different forms, but here's one example, and they can take on many different curvatures. That's what we're headed for. They're called exponential functions because they use exponents. So as you do your plugging in and getting out y values, you'll encounter exponents. So 2 to the third power is 8 because it's really, as you remember, 2 times 2 times 2. 2 times itself 3 times. It would be wise of you to make sure you could enter these into a calculator to get out these values to make sure you understand how to use your calculator for exponents. Every calculator seems to be a little different on how they do exponents, but look for keys like this, or if you're using a keyboard on a computer, the caret key will often be an exponent key, but there's certainly other ways that calculators use. So pictured up here is a living, breathing exponential function. You'd notice that it definitely does not look like y equals mx plus b. And over here I've made a partial t-chart. We could plug in any of these x values to get out certain y values, and I skipped a bunch of the x values. I just did 3 of them. But basically, if I had to plug in a -3 for x, then the -3 goes up there, so my exponential function is 4 times 2 to the -3rd power. And if you work that out on a calculator, you get a 0.5. Plug in a 0, you get out a 4. You plug in a 3, you get a 32. But I would warn you to practice this because it's not necessarily as straightforward as you think. A lot of people will think that they should do the 4 times 2 first, but beautiful Princess PEMDAS says that you need to do the exponents before the multiplication. So for example, in this problem down here, the exponent of 2 times 2 times 2, which is 8, has to be done before you do the multiply by 4. So again, it's up to you to make sure you could plug this into here to get this, to make sure you know how you're doing this. So if I took the information from the t-chart that I did up above here, and I made a graph out of it, I would get this nonlinear exponential function. Now there's a couple of things that are new on here and other things that are old hat to us that we've done before. For example, here's my y-intercept where the graph strikes the y-axis at 0, 4. Also, if I looked at this graph, it would continue to go upward and to the right forever, and it would continue to go towards the left forever. So the domain, which is any x value that would work in there, is all real numbers. Any x value would work in there. You can plug in any x to this equation and get out a y. Or my graph lives forever going to the left and lives forever going to the right. The range, which is the y values, in this case, my function continues to go upward forever, and as it goes to the left, it gets closer and closer to this x-axis, but it'll never cross over the x-axis. So the y values always stay in positive territory, or they're always larger than 0. A new thing that you might notice on this graph is this red dotted line, which is called the asymptote. And what that means is as this graph comes over to the left, it'll continue to get closer and closer to this level, but it'll never cross over it. So an asymptote is a spot that the graph approaches as it heads out, in this case, to -infinity, but it'll never touch it or never cross over it. At the top, I have 2 new exponential functions, and we're going to start taking a look at the different parts of it. Of course, they have exponents. That's why they're called exponential functions. But as you gain more experience with these, you're going to start noticing that this part right here is always going to represent the y-intercept, or the original amount when x equals 0. Then the number in the parentheses that has the exponent is going to be either the growth factor or the decay factor. And what we're going to find out is when this number is bigger than 1, we have a shape of an exponential graph that is going upward, and when this number is less than 1, we have a shape of an exponential graph that's going downward. So remember that anytime your growth factor is bigger than 1, you have an increasing exponential function, and anytime your growth or decay factor is less than 1, you have a decreasing exponential function. So if I looked at this exponential equation, I would know the original amount, or the y-intercept, is 200, and this would tell me that I have a decreasing exponential function. So the 200, the y-intercept, this tells me I have decreasing, and if I want to know exact points along the way, I can take any of these and plug them in to get out a y value. And like all exponential functions, as it travels, it'll never cross over an asymptote, it'll just approach a certain value. If I felt like it, I could put negative values into here and continue on this trend this way. But as you'll see when we do word problems, sometimes a negative value for your x or your t does not make sense. That's your introduction into exponential functions.